Hello, good afternoon, everyone. Thanks for joining this session and welcome on this tutorial afternoon. So the day actually before EuCNC starts. So we have 4 parts in the tutorial this afternoon. So the first one will be a general introduction on Fed4FIRE, on experimenting on the testbeds. A second part will be a hands-on demonstration how you can use those testbeds. And then we have 2 specific parts on Openwifi using very dedicated hardware. And that will be done by my colleague Wei and Xianyun. So thanks for joining, and let's start with this tutorial session. So maybe also regarding a timing. So the first part will take about 1.5 hours, and then we will have a short break of about 15 minutes, so at 3:30. And then we have another 1.5 hours about Open Wi-Fi. But let's start with experimentation on federated testbeds and Fed4FIRE. Maybe also, if you want to ask any question, please put it in the chat. We have some colleagues there that can help, maybe directly through the chat. But if we need it, we will handle the answer, the questions also at the end of each part. So don't worry and just ask your questions whenever you want to. So the first part is, well, what is Fed4FIRE now? Maybe you have heard about it, maybe you haven't, but let's first introduce that one. So Fed4FIRE is an EU project that is already running since 2012, so that's almost 10 years. And the goal of that was to make it easier to access testbeds. So with testbeds, there were a lot of testbeds available at that time, and also after that, some testbeds have joined. But the problem is that each testbed has its own account portal, has its own tools, its own documentation. So it's very cumbersome to use different testbeds, maybe together, maybe in series. So we wanted to make that easier. That's the only goal there. And you see, for instance, here an overview of the testbeds which are federated, which are usable through Fed4FIRE. With the colors, we give some ID on the technology supported by each testbed. So you see, for instance, green is wired, wireless is blue, orange is 5G. So you see that some of the testbeds do support multiple technologies. Some are focused on a single technology, but all of them are different. All of them have different hardware, have different functionality. The common functionality is, of course, the same, but it depends a bit. And that's the reason maybe sometimes one testbed is easier to use for your specific experiment or has the right hardware. Other times it's another testbed. So that's the reason we focused on that federation. So the goals of the federation, it's very simple. So we only want to make it easy for experimenters to use those multiple testbeds. So that means that with a single account that you can use those testbeds, and that also with a single tool or a small number of tools, you can use those testbeds. So that's the main goal. And then the question is, well, why would you need multiple testbeds? That's several reasons can be done for that. So the most the most obvious reason is, of course, if you want to scale up, you want to make your experiment bigger, you need more resources to do the experiment, and you want to combine multiple testbeds. So that's a simple reason. But there are also a lot of other reasons. So suppose you are doing a wireless experiment. Well, you know that the environment of that wireless experiment is very important. So it depends on the room, on how the walls look like, what results you will get. And that's the reason we have multiple wireless testbeds. If you do your same experiment on multiple testbeds, you will have different results, but you can learn from that. So that's also one of the reasons. Combined with that, different hardware. So for instance, you have a specific need for a wireless card for a software-defined radio, things like that. You want to pick out the right testbed for you. Um, And redundancy, that's also a good reason. So suppose you are doing class exercises and one testbed is not available, but you do need those resources now, well, then you can maybe move to another testbed and use the resources over there. So this is the basic setup of what we are aiming at. So design principles is, so we build a system that should survive over the years. So we started in 2012, so we already survived for 10 years. But the goal is to have this, this remaining for the coming years. So to have like a sustainable solution for that. And so what we aim at is that different components can appear and disappear. So for instance, testbeds is the most obvious one. Maybe a testbed comes new, for instance, IoT testbeds renew all the time, 5G, 6G testbeds can come up, and you should be able to add them to the federation. The same is true for identity providers. So where you have your account, so we also support multiple identity providers over there. For instance, in the beginning, we had also people with a Planet Lab accounts. People who still know Planet Lab know that it was a very nice testbed and a large testbed from some years ago. But for now, today, Planet Lab is not used. The accounts are not available anymore. So that identity provider does not exist anymore. But we, of course, have a Fed4FIRE portal, and it is possible that in the coming years, another identity provider shows up. So that's the system. It's very flexible. It's built for years in a very simple thing. And the main underlying system is that the testbed trusts those identity providers. So if a new identity provider comes in, well, the testbeds trust it, well, in the federation, of course, and you can use that account. That's how it works. To give you an idea of the usage, we have here some statistics on number of users. We have at the bottom 2013 till 2019. That's actually the first version of the portal. And then we started with a new portal, a new identity provider with new features in 2020. And that's the other graph that you see in lying. So you see that on the first portal in about 6 years, we had like 2,000 users. And now in the last 2 years, well, 1 year and a half, we have about 900 users already. So we started, both are still available, but actually they coexist here. So you see, it's really a lot of users. Maybe we have also another view on that. And that's a question typically asked, how many experiments are running on Fed4FIRE? And we have a statistic like this. And what we defined here is because if you did some experiments in the past, what you typically do is you have like a setup, you do a lot of experiments on there. Maybe the next day you do another experiment, and it all, well, contains in one subject, one topic, one research thing. And that's why we defined projects. And a project is actually something you define. You ask for a project, multiple users can join that project. So if you work together with a number of people, they can actually join the same project. And in that project, you can do multiple experiments that can go over maybe 1 month, that can be 2 years, that can be 1 year. So it depends on your needs. But for instance, a PhD is typically one project. So if you have like 3 to 5 years of PhD duration, all those experiments that you are running is one project. So you know that's actually a lot of experimentation. And here you see again the two graphs. So in the first 6 years, we had about 900 of those projects, and in the last 2 years, we already have again about 450, 500 projects. So it gives you a bit an idea how many of those projects do exist and are used there. And of course, a lot of experiments are done in each project. So the Fed4FIRE infrastructure, the testbeds, is really used by a lot of people. I focused in one of the previous slides on the testbeds that are federated. These were actually the European testbeds. So you see them here in the middle. But apart from that, we federated also with non-European testbeds. So for instance, in the US, we federated with Genie, with Cloud Lab, and you can also use the resources over there with your same Fed4FIRE account. The same for some Brazilian testbeds, some Japan, South Korea. So we also federated with them. And actually, I can show this live because this is a website, fedmon.fed4fire.eu that you see here. So this is actually a live monitoring, and here you see the same testbeds, and you can actually see the scale or the status of each testbed in this map. So green, of course, means that it is useful. If it's red, it means it's down, but you can see, for instance, here on these location, multiple testbeds are available, others are green. And you see also the number of free resources there. So you have a good view. If you want to use a specific location, specific testbed, you can actually have a look if it's available or not today. So also for Europe, you see this this thing. If I go to the homepage of this fedmon.fed4fire.eu website, you see a more elaborate view on the testbeds. So you see them in different categories. So you can select the category that you want, and you have a good view on all the available resources and the health. So for instance, if I look at this virtual one testbed, it has a health of 100%. If I click that one, I can see more details on, for instance, how did it go the last year in availability, the number of available resources. So you have a good view on, well, this testbed is okay to use or not, or maybe there's not enough resources available. So you have a good view. The reason that we have this this monitoring website is because you the federation is actually, it's not one organization. So it's an effort, it's an European project doing the federation, but actually each testbed is owned by, for instance, university, by research institute, and we do not have, well, management on that testbed. So what we do is we do very detailed monitoring to see if it's available or not, and we represent that to the experimenter. So in that way, you can actually see if it's useful or not today, for instance. So let's get back to the slides. So that's the view on the different testbeds as I have shown. And maybe now some example here on what you can do with Fed4FIRE. And Fed4FIRE is a meta testbed. So it actually means you can do whatever you want on the testbed because you have a very good access, bare metal access to the resources, so you can actually do what you want. So this is one of the testbeds called the virtual. That's the one that we will use in the hands-on exercise. And for instance, here depicted is you can deploy clouds on different nodes. You can deploy, for instance, 3 clouds. You define a network between those clouds. It can be software defined, so you have full control. It can be an SDN network, it can be OpenFlow, whatever you want. And then you can actually define something like Google over the world, because you have all the different components. You can play with those components, and you can do research on the different aspects there. So that's one of the typical examples of what can be done on the resources. We do have a tool called JFET, which is used to reserve those resources. And here you see some screenshots. So each node, each block, each square is actually a node or a resource on the testbed. So in this case, there are different virtual machines. For instance, here for a larger OpenFlow experiment. So you see the links between the different nodes. And then there was, some OpenFlow experimenting going on a larger scale. Here, you can see some other topologies, some different resources. And you see also on the left side, the different resources that you can ask for. So you can choose, pick and choose what you want. I will, of course, in the hands-on, we will show how that works. And here is a more complex experiment with resources in different locations, different testbeds, and they are combined, for instance, in this case, with GRE tunnels over the internet. So that's all possible. So actually, well, Fed4FIRE, because you have all that hardware available, going from wireless, wired, cloud, networking, you can actually, well, experiment very broadly with that. You can, of course, also create actually new platforms, new testbeds, new architectures for new internet. That's all possible and has been done before on Fed4FIRE. So suppose that's one of the demo experiments we have done in the past. So we wanted to show actually a very large scale experiment going over multiple testbeds, also US, EU combined. And so the story here is, suppose a company wants to deliver global video service. So that's actually a demo that we did, well, a lot of years ago, I think before Netflix even existed, but you can have the idea of that one. So suppose they want to do it, well, cost efficient, also redundant, of course. And that are the main goals. So what we looked like was, well, we will have users in the US and the EU, so people who will stream the videos in, of course, the different parts of the world, and how do we need to distribute the videos there? So what we did is we combined a number of testbeds, and you see every circle here is actually a different testbed. Some US testbeds, some EU testbeds were combined, and then we had actually a triangle network for the redundancy between Washington Software Defined Exchange, the one of iMind in Ghent, Belgium, and then also the Internet 2 in the US. And so we had a large bandwidth triangle, we had resources on the different testbeds, and we had also a link to Amazon Web Services through a dedicated layer 2 link, which was also combined in this. So then we put the video resources on some locations with the higher bandwidth, and then we put the virtual users on the other testbed. So that's how we could scale up the number of resources there. So how do you build such an experiment? Well, of course, you need to test your software, the networking, to see if it's right. So what you typically do is you start with such a prototype in a single testbed. So you see, for instance, here, you see the triangle, Cloud Lab, SDX, Wix, SDX iMinds, and then you have the different testbeds for some users, and you start small just to see if everything is working. So for instance, you see here a cache in the US, you see a cache in the EU, and you want to see if that all works. So before you reserve like, well, maybe 200 different resources on different testbeds, you want to make sure that everything is working as you intend. And that's a reason, start small, start to see if everything is working right. And then you start with upscaling. And for upscaling, what you do is you build like a backbone. So again, we know that, for instance, adding an end user, a virtual end user streaming the video, that is, if you test it once, then it's just copying and it will work. So instead, again, of emulating 500 users at once, you start with maybe 5 or 10 but your backbone should be there with all the videos, with the caches, that should be there. And that's what we built here, actually, as you see in multiple experiments, because each JFET screenshot is a different experiment. So you can actually combine experiments together. And you see the colors on the boxes that indicate the different testbeds. So you see that these are all different testbeds which are interconnected. And that's how you start. So here again, now we have, instead of a single testbed, we have multiple testbeds, and you start you test the interconnections to make sure that is right, that you have the right bandwidth. Maybe you can already start to test the redundancy by breaking a link and seeing if it gets through. And then you add the users to upscale. So that's simple. You create another experiment and you map them to the existing ones. And you say, okay, for instance, these are 200 users that I add. Maybe this is another 100, and then you need another 200, for instance. So this is how you build such an experiment. And these last upscale things is only maybe for 1 hour, for 2 hours, depending on your experiment, of course. But you try to limit the resources that you are using on the testbeds. But in the end, you can combine all this and you can actually use or create very large experiments worldwide, all with the same account, with the same JFET tool as shown. And then your real experiment is, of course, you want to see if your caches work. You have a random video streaming demands that you create. And then you see, for instance, also the day-night changes between the US, EU, the caches work. You break such a link to see that the traffic goes in the other way, and so more. So that's then really the experiment itself. Here then the day-night emulation. Also here, what we did is, instead of doing indeed a 24 hours test, we emulated this, and we started clients on the EU side, the US side, with just a bit faster than the normal 24 hours, but you can emulate this going on. And then you have tools like to automate this kind of thing. Other things that are possible still in the networking world is, for instance, network function virtualization. Also here, this did not exist before Fed4FIRE started, but actually people started this research on Fed4FIRE testbeds because they had the availability to do that. So for instance, if you have this kind of setup with different nodes, you can, for instance, add things like OpenVSwitch, you can add things like Click, and you have full access there and full control. So it's very easy to do, for instance, virtual network functions there in this way. Of course, an interesting and important thing is also to automate. As I talked, such an experiment like the big video experiment needs a lot of resources, and you may want to do some trials on that. So it's interesting to automate things, for instance, to install software automatically, to be able to redo an experiment, and this becomes also more and more important for papers where you have reproducible experiments, that you have also open data, that you can prove that your experiment really works. That's also one of the benefits of those open testbeds, that other people can verify what you have done or what you have published. And for that, we have something called an experiment specification, an e-spec. And what is it about? So you have three things. So you have a description of your resources, you have some files, some software to be uploaded, and you have some commands to be executed. So you can combine all this and put it in a single tarball and let it run automatically. There are some extras. So for instance, if you install software, complex software like an OpenStack or something, it needs some passwords and you want to generate them randomly. Also, the nodes should interact and you need an install script should maybe connect from one node to another to copy some configuration, some keys. And that is also done by this eSpec experiment specification, which is supported by JFET. So that's just to show that this is all possible in the end, that you can fully automate it. This is, for instance, used also a lot for class exercises, where the tutor wants to have the same environment for different classes, maybe year after year, or different groups. So for instance, we have at IMEC some classes which then run for, well, 150 students, and they have like 10 sessions with each like 15 students. And there they want to reproduce, of course, the same environment for all of them. And that's where this comes in handy. So as a conclusion of well, Fed4FIRE, so what we actually do is we combine computing, networking, storage, but also things like SDN, NFV, software-defined exchanges, machine learning, IoT, cloud. It is all combined in Fed4FIRE. So for instance, regarding machine learning, 2012, that was not that much of a research topic, or at least not broad, because there were not that many GPUs yet useful for that. Well, we added GPUs to the testbeds, I think like 6-7 years ago. And at that point, people could start with the machine learning. And in the last 3 years, it really has boomed, of course. But there you see, we didn't change a lot at the testbed. We added, of course, specific resources for this. The same for IoT, for instance, resources were added. But the main thing is, with the same account that people had in 2012, they now suddenly had access to machine learning, to Jupyter notebooks, for their research. So that's a bit the story here. I will just have a quick look if any questions come up. Not yet. Yeah. So then I'll start with the second part, and that's on the hands-on thing. So how do you now use those testbeds? And that's, well, a part called using the JFET tool to experiment from zero to hero. So JFET is actually the tool that we developed at the start of Fed4FIRE, and is the tool that didn't exist before. So we wanted to have that it worked, of course, with the identity provider of Fed4FIRE, and that it had access to all those testbeds. So that's how we developed JFET. Until now, it is still used as the most used tool in Fed4FIRE. So maybe what we will do in this tutorial is we will start very simple. So it will be a simple experiment with 2 nodes and a link in between. And then I will show some advanced features. So it's actually the starter tutorial, but for instance, what Wei will give in the second part is then a very advanced tutorial on, well, on Openwifi, so a specific topic, specific hardware. So you will see how that will go then. So she will also use Fed4FIRE accounts. She will also use JFET to do that. So the basics are the same, but it's just about other tools. So maybe let's start with how to get an account. That's, of course, the most important thing. And therefore, we do have a portal, of course. So that can be found here. So that's portal.fed4fire.eu, quite simple and straightforward. And there you can sign up for an account. So there are 2 possibilities there. If you have already an academic account of university, you can use EduGain. So you can actually search for your institute here. Ghent University is already listed, and you can actually use that login and password. to start. So that's quite simple. If that wouldn't work, or you are a company and are not listed there, you can of course create a local account here. Give us some information, very limited. So we do want to know if you're like a student or a researcher or an industrial researcher, and your country and city, but that's all. So then in the second step, you have some terms and conditions. So it's mostly on not using the testbeds or app using the testbeds, and only using them for non-commercial things. So you cannot run like a commercial web shop on our testbed. You can do the research for that, so the testing, but you are not allowed to run the commercial version itself, of course, obviously. And then you can create or join a project. So I won't go through those steps because that should be straightforward, but I will just log in and show you how it looks like. So you can have some view on that. So as said, the projects is the core here. So you can combine multiple users in a project, and you can also do multiple experiments in a project. So actually, it's like a research topic. As I said, a master thesis can be a PhD thesis, but also like an EU project, a research project. So you define one project and all the experiments go into that single project. So that combines a bit your efforts. And so for instance, if I take this one, you will see that you then have an overview of different users. And you, if you created a project, you can actually upgrade users to an administration role. So you can remove members, you can allow members, etc. So that's all possible. So you have actually here the administrative side where you can control the people. So you also have a view on the experiments that you did, maybe the running experiments, but also the experiments in the past. Because the interesting thing is sometimes you want to reuse, you said, well, last week I did an experiment, I had a certain topology, but I don't remember how to create it. Well, actually, all this is stored, and this is called resource specification. So it's actually, it specifies all the resources. I will come back to that. And you can download it from all the different experiments that you did in the past. If the experiment is still running, you see actually here a button open in JFET, and you can actually open immediately that experiment in JFET. So that's what can be done through this portal. And I started a specific project for today. So for instance, here you will see the project is called EuCNC, obviously. And then I have an expiration date on that, 8th of October. So for 4 months, you can actually use this. We have now 3 users in there. It's my 2 colleagues, Thijs and Wim. And we have done 0 experiments for now in there. But you can also have a specific, so the default thing is that you have an invite URL. So you can invite people by sending them this URL by email, and then they are able to join the project. You can also put it on auto approve. And so I will do this for this tutorial. And so actually, if I put this in the chat, you will be able to join this project. So if you want to join later on with JFET and do also some experiments, please click this link and you will be able to join this, this project for doing that experiments. So in the meantime, I will also upgrade my colleagues to administrator, and that's how it works. So that's where the portal is used for. So I think that's the most important thing here. Well, maybe one more thing. So you see here, I'm in 4 projects. It's also possible to request or join new projects. So for instance, if I want to create another project because I have another master thesis student or I'm involved in some other research topic, you just request a new project. The things that we are asking here is like the name of that project, some description, and the testbeds you want to use. So the mission works as follows. So if a new project is asked, then we as a portal administrator should admit that. So we need to process it and go through it. But if you ask another user to join one of your projects, you will be able to admit him or her. So that's how it works. So we actually distribute the processes here, and so we have some insights in how many projects are created. The reason is sometimes it's not clear which testbed it will be used, and then we try to go into some interaction with the experimenter to say, well, maybe that experiment should use that testbed. It could be more useful. So that's how you ask for a new project. If someone else has created a project and you want to join it, then you can just say request to join a project and you only need to put in the name. Of course, if you got that invite link through email or to something like direct messaging, you can also use that. So that's a portal. So of course, nothing too special on that. There's a screenshot in the slide just to show it. But now let's start with a basic experiment. And the tool that we're using, JFET, I already mentioned it a couple of times. You can download it from jfet.ilapt.imec.be. I will also show that. That website. So there's actually here the downloads. So of course it's for Windows, Mac, and Linux. We have different versions. So based on the platform you're on, you can install the right version. So it takes some downloads. For instance, for Windows, we also install, of course, an SSH client. Mac and Linux do already have this built in, but for Windows, you need to install PuTTY first. So that's, well, very straightforward, I would say. So you can do it in the meantime now. So that should work out. I have also already installed it, and I will just start it from here. So JFET Experimenter Toolkit. There's actually also a command line version. I will now show the graphical version. It's the most used, but also a lot of people use the command line version because that can help in automating. For instance, that example of classes where you want to set up, for instance, experiments for 15 groups of students. Well, using the command line version automates it quite well. So that's handy over there. So if JFET starts up, you do have this view, and these are all the different identity providers that I mentioned. So of course we will take login via Fed4FIRE, but as you see, also the US people with a Genie account can actually use JFET, or there's our legacy. That's the one that we used till 2 years ago. People can still use that, of course, as well. So I will now take Fed4FIRE. And what happens then is actually you get the same login screen as on the portal that I have shown. So again, here you can use an academic account, other institution, or you can use the local account on the portal. And I will use that one. Of course, if you forgot your password, etc., you can of course recover it. So let's sign in. This is something you can neglect for now. It's some more advanced thing, but don't save is the best option for now. It's documented. What does it mean? But it goes a bit too far for now. So then you have JFET with this blank canvas, and you have some buttons to open different things. So maybe let's just start with a new experiment to make it quite simple. And I'll just start with a very simple physical node. I will drag in 2 of them, and I'll drag a link in between. So that's just going close to the node, clicking, and then you drag the link to the other node. Then you can double click those different nodes and you get some properties. So in the properties, you see, for instance, that, well, the default testbed for this was virtual 2. If I click this, I can choose from all the other testbeds. But I will start this experiment and then I'll talk a bit on it while it's reserving. So the only thing I will do now is change the node name to server, and I'll call the other node client just to have some good naming. And I will also double click the link because also there you can put some specifics. So for instance, some impairments. So I will put a latency on it. So 100 milliseconds as an example, and that will be 100 milliseconds in both directions. So just to show what is possible. And then I run the example. You see here, I spoke about multiple projects. You can actually choose here in which project you will run this experiment. So I will choose the EuCNC and I will call it latency 2. By default, it will start for 2 hours. That's okay. I will not share it with all the other project members. So you can share an experiment with them or not, but I won't do this and I will just start it. So now while it is starting up, so actually what happens now is there are chosen 2 random nodes which fulfill the things that we asked, but that was not much. And we have an error. So let's release the resources and have a look what happens. Internal error creating group. So I think I know what happened. Maybe I see Wim is also present. So Wim, could you have a look on this internal error creating group? So what I'll do in the meantime is I will create it in another project because I know it will work over there. So instead of EuCNC, I will use my own project and do it over there. And then I hope that Wim can solve the issue by some time. So let's wait. So what happens now is, so the 2 random nodes are selected and they are actually rebooted. The image is flushed on it so that you have a brand new operating system. So even if someone used the nodes before, everything will be removed. The link will be configured between the 2 nodes. And if I asked for specific resources, specific operating system or specific names, for instance, it will be configured. And also my login information will be put on that. So my SSH key will be installed on the nodes so that I can log in afterwards. And all that takes minute or 3, 4 to do all this. So let's run this, and in the meantime, I will explain a bit more on JFET. So you see at the bottom, I have different tabs. So this one is a running experiment, but the blue one is still my experiment definition. So I can reuse this, can save it, and can extend it further. So maybe go into some more detail on that. So if I double click the properties of such a node, as I explained, you have multiple testbeds available. So I selected the physical node. That's the most common bare metal server. So it's a real server. It's not a virtual machine. And these are the testbeds which support this kind of resources. And then you can see the heart shows the health of each testbed. So you can, of course, if the testbed is red, then maybe today it is down or it's not useful. That saves you some time. So take a green one. And then the second, the bar, the column is showing how many free resources are available. So for instance, for the virtual 2, then you see some details. 46 of the nodes were available and 4 free IPv4 addresses. If you go, for instance, to Cloud Lab Utah, you will see that there are 346 available of the 900 for the moment. So depending on your needs, you can select My Testbed there. Disk images, also there, you have some possibilities. So we do have different images available here. So Ubuntu 14, 18, 16 should be there. But you can also create your own images. Well, actually, I'm now on Cloud Lab. So you can actually, if you have an experiment, you can create an image of a node and then you use it afterwards in another experiment. So I do not have any available images there, and I'll also maybe look for virtual 2. So the available images depend on the testbed. So you see now for the virtual 2, I also have an Ubuntu 20, 18, 16, even 12 is available, some Debian. So depending on the testbed, you can have other images available. So that can also be a reason to switch testbeds, for instance. Regarding the nodes, you can ask, for instance, for specific hardware. So for now, I just selected 2 random nodes because it's a very simple experiment. But sometimes it can be useful to have specific hardware. And you see here the different types of hardware and the number of free resources. The thing is, this is cryptical, but we have here a link called hardware info. And there you come to the documentation webpage that documents the different types. So if you can also choose a specific node. Suppose that you have done an experiment on this node before and you actually want to have this specific node again because, well, the specific setup or well, you want to really have the same setup again or compare different nodes to each other, you can actually also ask this specific node. In a second tab here of properties, we have also boot scripts. So you can, per node, you can install specific software. You can execute some commands. So think of an apt-get install whatever package. And actually, instead, I talked about creating an image, but sometimes, and in most cases, it's actually more useful to do a number of apt-get install commands to install some software, because that can be easily reused from testbed to testbed. It can also be used on, for instance, newer Ubuntu images. So it's easier to port your experiment. With an image, if you take an image on, for instance, Ubuntu 14, well, you are always bound to Ubuntu 14. And if you want to upgrade, it's more difficult. So that's a good reason to use this kind of commands. And then I also have the interface, so I can define the IP addresses. So by default, the testbed chooses an IP address for each link. So if I click the link, I can actually see this here. So the server will get the .1, while the client will get the .2 address. But of course, you can change that beforehand. So that's a first look. Yeah. So in the meantime, you see that that the experiment is ready. So the nodes have become green. So that means everything is right. You see also here, also the connectivity is ready. So I can log in on the nodes and everything has been set. At the bottom, you see how long the experiment will run. So remember the 2 hours that were presented. And so I have 1 hour and 53 minutes left. So maybe a first important thing is, if you want, because now I see that the experiment is ready, that everything is right, you can also renew this experiment and extend it in time. So suppose that I want to extend it for like 1 week, I would just do it like this, renew, and then all the resources will be provisioned or reserved for 1 week. So that's very important, because sometimes in the beginning you're using, sometimes people lose resources because of that. You also get an email 1 week before, 24 hours before the end, and I think even 1 hour before the end, that the resources will expire. So it's important that you have a look at it. So, but let's go look at that experiment. If I double click, it will open an SSH session. It's the first time I log in on that node, so I just click yes, and you will see I'm logged in on the node. I will just enlarge the font a bit to make it better visible to you. So you see, I'm logged in on the server with my account, and you also see I did not put in any login or password information. So actually in the back, everything has been done automatically to log in with SSH keys, which is one, very secure, and two, it's very easy because of this automatic thing. So that's how the login works. And now you see also the advantage of the node naming I did, like server and client, because if I see this window, I know I'm on the server. If I open up the second one, you will see I am on the client. So that always helps to do your experiment in between. So now simple things can be done as ping to the clients. And what you see here is a round trip time of 200 milliseconds. So remember the impairment that we installed of 100 milliseconds in each direction. So in total for a ping, that's a return time of 200 milliseconds. So you see that that works as is. And the link is set up. The IP addresses are there and can be used. So you see that 192.168.0.1. And you also see here a second interface with an IP address 10.2 in this case. This is actually the control interface. So that's an extra interface which is used to log in. So actually you see here one link between the two nodes, but each node has also a control interface which is used for login. So that means that I can just become root. So that's another important one. You can just become root on all nodes. And then I can just turn off that ETH0 link. And then of course the ping will not work anymore. So that's the easy thing. On the experimenter interfaces you can change IP addresses, you can put IPv6, IPv10 on them, you can do your experiments, while the control interface is the one that is used for login. How do we do that login? Well, actually, we use IPv6. And so you see here a public IPv6 address. So all those nodes have public IPv6 addresses, and we use that to log in. So you may say, well, I do not have IPv6 at home or wherever I am. Well, JFET takes care for you of that. So you will see here at the bottom of JFET, proxy enabled for SSH sessions. So this means that also if you only have IPv4, JFET will tunnel actually or proxy the SSH session through IPv4 and then goes IPv6 to the node. So that's also something JFET does in the background and makes that the login is typically not a single problem to do. It's because that's also not your experiment. You want to be on the nodes. So as I have shown with sudo su, your root on the nodes. You can do software installations. You can reconfigure the node, etc. So that's all possible. Suppose now, well, I already disabled the ETH0, which is actually the experiment interface. Suppose now I'm a student and I do something wrong, like I put down my control interface. Well, now I'm lost control on that node. So typically that would mean in the past you have to run to the lab to just reboot your node because you lost some connection. The same if you are experimenting with firewalling. So maybe some people have done this in the past. If you put in the wrong rule, well, you lost control. Well, also there the testbeds do work around this. If I right click on this node, I have some options, and the options are, well, the first one, OpenSSH terminal, that's what I did. But then you see also here reboot. And actually I will just click that one. So now the server will be rebooted from a management interface, and then it should come up again with all the links. So you see that you have a lot of control over your experiment, because apart from reboot, you have also reload operating system. So suppose that you have experimented with a Linux kernel and that you, well, mixed up a couple of things and that it doesn't boot anymore. Well, you can do a reload of the operating system. And that means that a fresh operating system will be put on the server again, and you can start from scratch on that node. So it's really meant for this kind of experimentation. Create image, that was the other thing I have shown or talked about, that you can create an image of that. You can also show node info. This gives also an error, I see. So I will submit that. That's another for Wim. So here you see the node has now been rebooted and it is green again. I will now just log in on that server, and you see I'm again logged in. I will just increase the font. And just to show you, I will show the uptime. So you see it's 1 minute up, and I have again my interfaces, ETH0 and ETH4. So even if I break things, I can recover. I don't need a human to intervene. I can do it middle in the night. If I'm on my experimenting for a deadline, I have full control over the nodes. So that's a very important thing. Something else. Yeah, I think that's the most important about this simple experiment. So maybe let's show you a number of other things. So JFET is only used to set up the experiment and to create the access. So that means if I will just close this Windows to clean up my desktop a bit. If I now just close JFET like this. So actually this experiment is still running. So the servers are there, whatever service they were doing, the job, they will keep on running. So what I'll do is if I start up JFET again the next day, I can have access again to that experiment. And I'll show you how that works. So I log in again in JFET. I have the blank screen, and here I do have a button called Recover. And with Recover, I do see all the running experiments I have. So these are 2 experiments I did before. One was broken, but I see here this one is still active and it will expire in 1 hour and 43 minutes. So again, here you have some warning that you see, okay, I need to look at that at that experiment, and then you can recover. So now JFET will reattach to those resources, and you have the same view again. So my 2 nodes are ready. I double click and I'm logged in on that. So that means JFET is only setting up and having access again, but apart from that, your experiment, your servers are running in between. So that's important to remember. So renew, I already explained this. This is if you want to extend the duration of your experiment. You can do this again and again. So what we do is by default, you can only extend it for 3 months, but of course you can extend it each time again. So the reason here is we want to clean up the resources. So we do like that people free their resources when needed, when they are not needed anymore. So that's actually the terminate button. If I click that one, the experiment will be cleaned up, and I will lose everything that is there. So that's an important button to not miss. Reboot is if you want to reboot all the nodes, sometimes that's possible. So instead of right-clicking nodes, you want to reboot them all. If you have, for instance, 20 different nodes, that might be more easy to do. Edit SSH keys, that's also an interesting one. But let's start with the share. That's easier to explain. So suppose now I'm the only person having access to this experiment. If I want to and I'm actually because I'm alone in the group, no more names are there. If it's in a project where multiple users are in there, they will be added here, and you can just add them simply. If not, you can also type in the login name if you know it, and so then you can just share the experiment with, for instance, with my colleague Wim. You do share, and then what happens is. If he clicks the recover in JFET, he will see that experiment listed and he can recover and will have the same view. And the second thing that is done is that his SSH keys are also put on a node so that he can actually log in. So that means he also has full control on that. So he can actually reboot the nodes, he can terminate, he can renew the experiment, and he can also log in. And again, some error. I mistyped his login name. So I think on this new portal, he has another login name. Yeah. So that's you need to know the exact login name. That's important. But that doesn't change the thing. So as I said, if you share the experiment with someone else, then he will have full control and be able to terminate it. However, you can also do another thing. If you only want to give SSH access, you can add only his SSH key to the node. So what happens is you see here some SSH keys. Well, you can just add a line here and say, okay, Wim can now log in on the node. You give him also the IP address of the node, of course, and then he can just log in. In that way, he cannot bother with the experiment itself. He cannot terminate it. He cannot reboot nodes, etc. So it's like if you work with students, sometimes this is the better option, that you only give them SSH access. Of course, you can also do the reverse. So to unshare, if you have shared it and then you want to unshare again, you can test the links. So for one link, you can just do a ping yourself. But if there's a lot of links in your experiment, you can just do a simple test of all those links at once so that it is easy to be sure that everything is working for you. I talked about the experiment specifications to automate. You can actually rerun or run such an experiment specification also if an experiment is running. So sometimes, for instance, if you do those reload operating systems, you want to rerun the automatic software configuration again to make sure everything is set up. So that's this button. Multi-command, that's an interesting one. So if you have a lot of nodes and you want to run the same command on them, so suppose, for instance, that you want to do a sudo apt-get install iperf. Well, it will be apt-get update and apt-get install iperf. You click the nodes that you want to run on that, and you run that command. So now you see a lot of is going on, and I can actually follow the progress of that in this dialog box. So it will run actually all those commands in here, and in the end will install the software. So that can be used if you have a lot of nodes and you want to do some things in parallel. That's always easy to do. So I think if I click this, so you see if I click this command, I see the apt-get update, and then apt-get install iperf, but iperf was already installed, so it doesn't do it much. So you can actually follow this up on the different servers, and all was fine. So instead of logging in on the different machines and doing those commands manually, we have some automation here. Yeah, maybe now something more in general before I come back to the extra things. So if you do such a new canvas to define an experiment, you see here at the left the different kind of resources. So you see, well, wireless, IoT, 5G things. So for instance, if I take a wireless node, then you have other testbeds available. So we will use in the second part of this tutorial, we'll use the YLab2 testbed. And actually, so depending, so for instance, for the wireless testbeds, you typically want to have specific nodes because you want to know the location. And if I click this one, you actually have a floor map of the different nodes because in wireless is important. Do you have two nodes which are next to each other, or maybe you want two nodes which are apart from each other? So that's a reason here you can actually use the floor plan to select those nodes. That's an important one. Let's just remove that and come back to my experiment that I did in the first step. So this definition, I have here a tab RSpec editor. So RSpec is a resource specification. And here you see that actually this is all defined in XML. So you see here a node, the first node defined, you see the second node defined, and then you see a link between the two nodes. So this means I can also, if I change here, for instance, the name. So we have node 0. If I change here server and I go back to topology, it is also changed here. So that means those XMLs, and I can just paste in some XML codes. I can generate those also with scripts. So for instance, if you want to have some automation, some larger experiments, maybe you want to script this kind of thing. You make just a shell script, a Python script to generate that code. Well, this is all possible, of course. And it is also possible to save this and give it to someone else so that he can create the same experiment, or that you save it for future use. That's all possible. And we do have some verification here because, of course, if you type in some XML, it might be wrong. We have also search and replace because sometimes you want to change in bulk some things. That's all possible. That's the RSpec editor. And the thing was, you have the same here in a running experiment, and then it's called a manifest RSpec, because I just picked out two different nodes, two random nodes actually. And for a running experiment, this is replaced by real nodes. And that information can be found actually in the RSpec manifest, the thing that you see here. So for instance, here you see the real nodes that are named. This can be interesting to document your research, of course, so that for specific experiment you have specific nodes. And you see here, it's actually a very similar XML. Try to enlarge this a bit. So it's a very similar XML. So I again see that nodes tag server, but here you see that there's added information about the authentication, which says it's port 22 user Beaver Mule. It also says it fills in the specific node or server. You see it here. So the email app fee node is N111304 or 06, and the hardware type is PC Gen 6. So it chooses it randomly, but I do have the information. So if I want to know what I have regarding nodes, I can know this. So that is the manifest information, and that's the save manifest. You can save this also. You can save this locally, because indeed, if you run different experiments, this can be interesting to know, well, on which nodes did my experiment run? I want to rerun it, etc. This information can also be exported as Ansible information, so that it is easy to make an Ansible script that logs in on the different nodes. Because every time I run this experiment, and if I do not specify the specific nodes, the node names may differ. So this export covers that, and you can be easy to rerun the information after that. So that's the reason we have all this information. Then after about scaling up, I already mentioned that XML, you can just script it somehow, but of course also in the user interface, we have some interesting buttons for that. So if you click a node and you click on duplicate, you can actually easily scale up this, and then you do just like an auto layout, and you have an easy scaled up version of it. Of course, you can then drag extra links, etc. So that's how it is easy to scale up things. You see the node naming is automatically done for you, and you will see that now my RSpec is a bigger defined as such. So that's the basics. So maybe I should also show you that, of course, this is all documented. So the things I have shown today on doc.fed4fire.eu, you have these basic sets here. So for instance, your first experiment, this is exactly what I have done today. So you can, of course, go back to this and do it again. And then we do have testbed documentation. So per testbed, there is some specific documentation on how to use it on specific features, which is, of course, very important. So for instance, for the virtual, the testbed I have used, then you come on this with, for instance, an overview of the different hardware, so that you can know, okay, this is available, I want to use this. Or you have specific things as how to run an OpenStack on the virtual. Well, then we have also tutorial documentation on that. So that's very important as well. And I'll look back to my slides now to see if I have covered everything. So that's the basic experiment we have done. I think I have covered also most of that. Yeah. Yeah, that's maybe an interesting one. So if you think about automating things, I mentioned the nodes are chosen randomly. So how does your code, your software, your script know on which node it runs? And also there we have some tools for that, which is called the Genie get command. So let's go back and log in on one of those nodes to show this. And increase the font a bit. So the command Genie get is available. And a first one is a Genie get client ID, and you will see what this gives. So this gives actually that name server. So that means I named them server and client. So suppose I have a specific script that runs on the server, a specific that runs on the client, I can build in that it checks if it's running on the server or on the client. So to make sure that you not mix up things. So that's a very basic thing, but you need these things available to get your things working. And actually, Genie gets, if you do -a, you get all the information there. So you see it's actually all the information that is available, also that full resource specification, the links, etc. It's all in there. But the scripts that we have added, this one, this order is a bit. So this is a Python script. So it shows you how to access the information from Python. So I have downloaded it. I will make it executable, and then I execute it. So then you will see the information that is in there. So for instance, another important one is my control network interface. So as I mentioned, every node has that control interface where you log in, and then it has the experiment interfaces. But of course, sometimes it's important to know what is the control interface, what is the IP address there. Well, you see that script does get it. So the device, ETH4, of course, this can differ. Some nodes that will be ETH0, on other nodes that will be ENO, also depending on the operating system, the version of, for instance, Ubuntu. This will change. I also get that IPv4 address, IPv6, etc. And then I have the same information for the experiment interfaces. So in that way, I can actually easily use this information in a script. I can also, as I said, there's a private IPv4 address assigned and a public IPv6. I can ask also for a pool of public IPv4 addresses, and then I can assign them to the nodes. So that's in JFET like this. So I'll go to that definition. So here at the bottom, you have address pool. You drag this in, you double click it, and then you can ask for a number of IPv4 addresses. Of course, take it on the same testbed as you have put the resources. And then you will get one or maybe more if you ask IP addresses that you can assign freely to one of the nodes in your experiment. So in that way, you can assign public IPv4. We do not do it for every node because we do not have enough IPv4 addresses. And also it's more secure to not do it for every experiment because most of the experiments do not need public IPv4 addresses. But if you do that and you want to have some automatic scripts, well, then also here you will have the information through the script. So you will we just provided it as an example so that you can easily see how to get the information out of it. So that's an interesting thing to mention as well. And renewing the SSH keys, yes, I have all shown that. We have also put down the control interface and rebooted the node, so that has also been shown. That's also an important. You have seen I had a couple of bugs in the during my run. I just installed the latest new version, so maybe that was not a good idea for this tutorial. But anyway, so if you run in such a bug, there's actually under the general tab here, feedback bug report, and then you can put in some information. So maybe you have just a question, you have a feature request, or you have a specific bug on a testbed or on JFET. You can actually provide all the right information here, and we will have access to all the background information of JFET just to have a better understanding of what's out and wrong. So this is the best way if you run into something that might not work as you expected. Just submit such a bug report and we can answer that for you. So you see, for instance, also we have the environment that you are running on, so that makes sure that things are working. So very important on that one. Yeah, maybe something I have not shown yet, preferences. So most probably you will never have to change anything in here, but you can. There is, for instance, importing an SSH authentication. Suppose that you already have an SSH public-private key that you are using a lot. You can add your own SSH public key in JFET. You see it here, and use that as a login thing. So that makes it easier for your command line access, etc. So that might be interesting. Regarding PuTTY, you can add a number of things. So PuTTY can also forward X11 connections. So that's graphical applications that you would run on a server. That can also be forwarded over PuTTY, also over other SSH clients, of course. And then the forward of the SSH agent. So I said that the SSH login works transparently in the background. I never had to put in some login and password. Well, actually, what we do is we put the public SSH key on the node, and then the private key is added to a local SSH agent. So if I, on Windows here, my SSH agent will be Pagent. So that's the one of PuTTY. And you see that a number of keys have been added here. So these two are actually added by JFET, and this is my normal SSH public key. So you see these are added to Pagent, and then the automatic login works. What does now do the forward SSH agent? So suppose that I'm logging in on node 1, and from node 1 I log in on to node 2. Well, that's where the SSH information will be spread over the different nodes. So that's forwarding SSH agent. The proxy thing is another thing. So you can, we have a proxy for two things. So for the SSH login, and the most important there is to work around IPv6 restrictions. If you do not have IPv6, then this proxy setting for SSH connections makes that it works. And the other one, proxy for JFET, is actually all the API calls that JFET does. They are sometimes on ports which are blocked on, well, firewalls, on hotel networks, etc. Well, also those can be put through the proxy. So what you do for that is you run the proxy test first, so that we are sure you can access the proxy, and then you can also put on, for instance, that one. I do not use it because it works for me and it goes a bit faster if JFET can do the calls directly. And I think this is the most important. Sometimes if you contact support, they will ask to put in some other things, but the rest is not useful for general usage, I think. Just go back to the slide. So if you have any question, just put it in the chat and I'll try to answer it afterwards. I'll just go through this. Yeah, I've shown that. Preferences. Yeah. So actually, most of the things I wanted to say, if not all. So my next thing would be is just try this out first and see how it works for you. And then from there, you can do the real experimentation. Some more advanced things that I didn't mention is like that eSpec. You can just open it even from a GitHub repository. It can be a local tarball, and that does everything for you. So that's the most easy if you, for instance, want to give a quick start to a student and you prepare everything. You just give that to him and he can start. Yeah, I think this should cover most of the things. So I don't see any question yet. Maybe Wim, I will, were you able to fix that bug on the group creation? It should work. Okay. Maybe we have still 4 minutes left. So to make sure, let's just start it. I will not run this complex one, but just to make sure that things are working, let's try it. So on the EuCNC group, it's always a good way of working to have every experiment a new name, because then you do not have overlap. It's the best thing to work with. So let's just see if this works now. And so I put in the link here for joining that group. So if you want to do some experimentation or some testing, you can just use that link and work forward with that. And I think now it's indeed better. So it's working. So you can just add your account there and start downloading JFit and working with that. So in the next part, so now we're almost 3:30. Let's have a break of about 50 minutes. There will be playing some videos by EuCNC, and then we can come back a 3:45, and then we will give the tutorial on Openwifi. In the meantime, if you would have any question, you can still put it in the chat and we will answer it after that. So thanks a lot for joining. And we'll see you back in about 50 minutes, so 3:45. And now I will stop sharing my screen and give back to EuCNC for some control. So thanks a lot and see you. So in the meantime, now it is green also on the EuCNC project. So thanks and see you again in 50 minutes.